Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today we will discuss about friction in extreme conditions and what are the thermal concentrations in engineering tribology. So what is the engineering tribology, and then so what are the major factors involved in engineering tribology? Already we have studied in previous topics. So today we will see the friction in extreme conditions. What is the effect of this friction on this wear properties, and then lubrication, and then overall engineering tribology. So the first topic is friction in extreme conditions, and then thermal concentrations in sliding contact. What are the important concentrations, thermal concentrations in sliding contact surfaces? Already we know sliding contact surfaces and rolling contact surfaces are there. So what are the major thermal concentrations we have to take, and then examples for these thermal concentrations? Similarly, the examples for the friction in extreme conditions. So what factors mainly we should focus in these extreme conditions, we will see. The first one is friction in extreme conditions. Actually, it refers to the behavior of friction forces between two surfaces, so when subjected to extreme environmental or operational conditions. So whenever two surfaces are in contact, so there what is the behavior of the frictional force under a certain load? So frictional force, friction in extreme conditions, it studies on these factors. So these conditions can include high temperatures, high pressures, extreme speeds, or exposure to harsh chemicals or environments. So these are the extreme conditions. So one is high temperature. Whenever they subjected to surfaces to high temperatures, and whenever surfaces are subjected to high pressure, they similarly extreme speeds, or it may be exposure to very dangerous chemicals or certain environments, like high moisture conditions. So like that. So the conditions involved in this friction in extreme condition. So first one, high temperatures. At high temperatures, so the materials can soften or deform, altering their surface properties and affecting friction. So suppose the high temperature, the material is subjected to high temperatures, then the material may be ductile due to ductility property, soften the material, and then it deform. So it means elongate lengthwise or diameter ways due to this high temperature. So increasing or decreasing of this material properties, or so material dimensions. So what will happen? The surface, it affects the surface properties. So the surface properties whenever changed, then immediately it leads to cause friction properties, so affecting the friction. So lubricants may evaporate or degrade, leading to increased friction and wear. So lubricants, so sometimes it may be evaporate or degrade. So what will happen? All these conditions leads to increase the friction. So whenever increase the friction, then there will be wear. So that we should concentrate on these conditions. So always see the material surfaces are uh, not affected in these conditions. Next, high pressures. So high pressures environments can cause deformation of materials, leading to changes in surface roughness and contact area, affecting frictional behavior. So whenever the high pressure, high loads are the surface are subjected to high pressure loads. So due to this load, what will happen? Some changes occurred in their dimensions. So that means automatically whenever the dimensions are changing, there will be a reduction of area or increasing area. So that the surface roughness and contact area also affected. So all these factors leads to finally increase the friction force. So under extreme pressures, materials they may undergo phase changes affecting their frictional properties. So this one also one cause. So under high extreme pressures, the materials may undergo phase changes. So it may be change one phase to another phase changes are possible. So due to this, the frictional rate and frictional force and wear rate also will increase. Extreme speeds. So whenever the contacting surfaces, so suppose to take machine elements, two machine elements are in a relative motion. So whenever these elements are subjected to extreme speeds, so then due to high speed, the pressure will be increased. And surface heating also will increase. So all these factors leads to changes in contact area and then contact mechanics. So the frictional behavior can change significantly at high speeds, and due to fluid dynamics effects, the material degradation also possible. High speed friction leads to wear, heat generation, and material degradation. Like this, all factors leads to damage the surfaces. Next, harsh environments. So exposure to harsh chemicals and abrasive particles, so other foreign materials, or corrosive atmospheres can alter surface properties and affect frictional behavior. So contaminants can also act as abrasive agents, increasing wear and friction. So due to the harsh chemicals and abrasive particles, wear will increase and friction also will increase. So that's why always the engineer should avoid these harsh environmental conditions. Better to keep in a safe place. Next, some specialized applications. Friction in extreme conditions is of particular concern in specialized applications. So sometimes these extreme conditions are required for some applications. Examples here, there's aerospace automotive racing, car racing, deep sea exploration, and industrial process where components operate in a demanding environments. Where the components demands this type of environments. Those conditions, the friction in extreme conditions are applicable. Here are some examples of friction in extreme conditions given. One is aerospace applications. Aircraft and spacecraft. These two components often operate in extreme conditions. So extreme conditions means one is high speed, high temperature, and high vacuum environments required for this application in aerospace. So friction between moving parts such as landing gear mechanisms and control surfaces and rocket engine components is critical to consider. So that engineers design specialized materials, coatings, and lubrication systems to withstand these extreme conditions and ensure reliable operations. So always the engineer should select the specialized materials to withstand these extreme conditions like high speed and high temperatures and vacuum environments. Clear? Next example, high speed machinery. The industrial machinery such as turbines, compressors, and high speed rotating equipment operates at extreme speeds, leading to significant frictional forces and heat generation. So, industry machinery such as turbines, compressors, these are required high speed pressure and so operates at sometimes high temperature. So it leads to increase the frictional force. So automatically, whenever the frictional force increase, the heat generation also increase. So friction between rotating components such as bearings. A bearing is a rotating component, mission element. Oil seals and then gears can cause wear, vibration, and premature failure. So all these leads to failure of the component and also leads to cause wear. So engineers employ advanced material to avoid these type of failures. Employ advanced materials, lubricants, always use proper lubricants, selected lubricants. So according to Society of Automobile Engineers, lubricants use and then cooling systems, proper cooling systems to manage friction and ensure reliable operation of high-speed machinery. So next, automotive racing. Next example, motorsports vehicles, including Formula One cars, endure extreme conditions during races with high speeds, rapid accelerations, and intense mechanical stresses. So these are the examples for friction in extreme conditions. Friction between tires and road surfaces, brake pads, discs, and engine components is critical for performance and safety. Engineers continuously innovate in materials, always innovate in materials, tire components, braking systems, and lubricants to optimize friction and enhance vehicle performance in these demanding conditions. So that what they have to do, engineers always testing for new materials, always think for better systems, always innovate in materials or braking systems and lubricants to optimize the friction. So finally, the aim is to reduce the friction and then at the same time enhance the and the performance, improve the efficiency of the components of the machine elements under these demanding conditions, under these extreme conditions. Next one. The next topic is thermal concentrations in sliding contact surfaces. Thermal concentrations. What are the thermal conditions important whenever the sliding contact is present? So it is very critical, the thermal concentration area in the sliding contact. Why? Because due to the generation of heat at the interface between two surfaces in relative motion, this heat generation occurs due to frictional forces and finally can lead to several important effects and concentrations. Due to this the sliding contact, more force is required. So due to this high force, frictional force, wear also will present, lot of heat will be generated. So finally leads to several effects and concentrations we will see. One is temperature distribution. So frictional heating causes temperature increases at the interface and the distribution of temperature across the contacting surfaces. It depends on factors such as sliding speed, applied load, and material properties and lubrication. So understanding this distribution is crucial for predicting wear, material deformation, and a potential failure modes. So in this, the temperature distribution mainly depends on sliding speed and what is the applied load and what are the material properties and which type of lubrication systems presented. So all these affects the temperature distribution, causes friction. Next, heat transfer mechanisms. So heat generated during sliding contact can transfer through the contacting surfaces via conduction and convection properties. So heat transfer generally three types of mechanisms there. Already you know. One is convection, convection, and radiation. So in some cases, radiation may also play a role, particularly at very high temperatures. So generally, convection and convection will play a major role, and sometimes this radiation also play an important role. The efficiency of heat transfer mechanisms influences the temperature rise and thermal gradients within the components. The heat transfer mechanisms: conduction, convection, and radiation influence the temperature rise and thermal gradients. Next, thermal expansion. Elevated temperatures can cause thermal expansion of the contacting surfaces, potentially altering the dimensional stability of the components and affecting their performance. So, differential thermal expansion between mating surfaces can lead to stress concentrations and dimensional changes, impacting the integrity of the system. So, differential thermal expansion between mating surfaces to contacting surfaces lead to stress concentration. And also dimensional changes will be possible. Next, material behavior. So, elevated temperatures can alter the mechanical properties of material in contact, such as hardness, strength and ductility, malleability, a creep, so toughness. These are the mechanical properties. So these properties may be changed. This can affect the wear resistance and deformation behavior of the surfaces. Influence the overall performance and the lifespan of the system. Next, thermal damage. So excessive heat generation can lead to thermal damage. Certain heat is required for the system. Up to within the limit, there is no problem. Whenever crossed this limit, it leads to thermal damage, such as examples surface oxidation, and then metallurgical changes and material degradation. These effects can compromise the integrity and functionality of the components, leading to premature failure. Next, lubrication and cooling. Proper lubrication and cooling strategies are essential for managing heat generation and controlling the temperature rise in sliding contacts. Proper lubrication system is required and a proper cooling system is required for particular system to minimize the heat generation. Lubricants act as thermal barriers, reducing frictional heating and wear, while cooling systems dissipate heat from the contact zone. So in cooling systems, what will happen generally? Whatever heat generated inside the contact surfaces, that heat dissipate to the surroundings. So how much heat generated and how much heat dissipated, that one also you can calculate. So based on this calculation dissipation of heat, you can say the system is required cooling or not. So that you can maintain the temperatures within the acceptable limits. Design considerations. While designing any sliding components, machine elements, engineers must consider thermal effects in the design of sliding components, including material selection, surface coatings, geometry optimization, and lubrication systems. So the major design considerations are material selection, surface coatings, geometry optimization, and lubrication systems. By accounting for these thermal considerations during the design phase, they can enhance the performance, reliability, and life of sliding systems. So overall thermal considerations play a crucial role in the behavior and performance of sliding contact surfaces, influencing factors such as wear, material properties, and system reliability. So effective management of thermal effects is essential for ensuring optimal performance and longevity in various engineering applications. So here, given some examples for thermal concentrations in sliding contact. So one is the brake systems. In automotive brake systems, friction between brake pads and rotors generates heat during braking. So whenever you apply brake to stop the vehicle, then heat will be generated. So the thermal considerations are crucial to prevent overheating, brake fade, and thermal degradation of components. By selecting the proper material, by selecting the proper lubrication system, you can minimize the heat and you can minimize the friction. So ultimately, wear also will be reduced. So engineers design braking system with materials, coatings, and cooling mechanisms to manage thermal effects and ensure consistent braking performance. Next example, railway applications. So generally in railway systems, the contact between train wheels and rails experience significant friction. So there is a suppose a wheel and is a rail. So that in between these two surfaces there is a friction, so leading to heat generation. So thermal considerations are essential to prevent excessive wear and material damage at the wheel-rail interface, so that the engineers employ materials with high thermal conductivity, lubrication systems, and high thermal management techniques to control temperatures and maintain tank integrity. Those materials engineers have to select. Next, metal forming process in mechanical systems during metal forming operations such as forging or rolling, sliding contact between workpieces and dies generates heat due to friction. In lathe machine, drilling machine, milling machine. So the contact between the workpiece and tool, it gives more friction. So thermal considerations are critical to prevent this tool wear and surface defects and dimensional inaccuracies. So engineers optimize the process parameters, tool parameters, and cooling strategies to manage thermal effects and enhance product quality. Next, machine tool sideways. In machine tool, sliding contact occurs between moving parts such as guideways and slides. The frictional heating at these interfaces can lead to thermal expansion and dimensional instability and reduced machining accuracy. So that the thermal concentrations are essential in machine tooling design to minimize heat generation. You should consider thermal effects while designing this type of tools for improved thermal stability and to maintain precision during machining operations. Conveyor systems. In industrial conveyor systems, sliding contact between belts and pulleys generates heat due to friction. The sliding contact between the belts and pulleys. Heat will be generated due to the friction. So thermal considerations are important to prevent belt wear, premature failure and material degradation. So engineers employ proper lubrication, proper material selection and cooling methods to manage thermal effects and optimize conveyor performance and reliability. Now sliding bearings. In machinery and equipment, sliding bearings experience frictional heating during operation. Example, journal bearing is a sliding contact bearing. So thermal concentrations are crucial to prevent bearing overheating, premature wear and lubricant breakdown. So that engineers design bearings with proper material, proper lubrication systems and optimized for thermal management, ensuring smooth operation and extended service life. In each of these examples, managing thermal effects is essential for maintaining performance, reliability, and the life of the sliding contact applications. And engineers employ various techniques, including material selection, lubrication, cooling, and design optimization to effectively manage the heat generation and control temperatures within the acceptable limits. So that's why in design of machine elements, the engineer should concentrate on these manufacturing considerations and design considerations and thermal considerations and environmental conditions also engineer should check before selecting the material and before selecting the proper lubrication system, the cooling systems. So then only optimum design will be possible. So they can suggest the optimal design to minimize this heat and minimize friction and minimize wear. And also the control temperatures within the acceptable limits. They suppose they have used proper techniques. So in engineering typology, the friction in extreme conditions and similarly the thermal concentrations in sliding contact surfaces plays very important role. So these are the references I've taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.